Okay, let's get moving. Starting the stream right now. So we have come to a point where all the instructions on the testing room that we was testing are perfectly working, and now the next error that we are having are instructions specific to the NES. So this one is the opcode 4, that is a no operation specific for the NES. So this is what was said in this paragraph, saying it looks like the CPU doesn't know how to interpret the opcode 04. Here is the bad news. There are about 110 unofficial CPU instructions. Most of the real NES games use them a lot. For us to move on, we will need to implement them all. So we got some sources in here about those instructions, and I think because of the way that we have been doing the previous development, that this one is the one that I would prefer to use as a reference, because it looks much more similar. So I think I will move it to the corner and do the same as before, reading this code or the instructions from here and implementing them on the go. So, questions. There are some things that we could do. One of them is creating a table like before, using this. No, not this table. Maybe this one. This one has a table. But it is not clear. I think the ones on board are the ones that are specific to the NES. Hey, Cricket, welcome! Holds the world record for emulating NES in GdScript. Is there a world record for that? I didn't know of it. So, drinking some tea, give me a second. Anyway, I don't like this table very much because it is mixing the previous and new instructions. So let's close it and let's see the other one. This one seems to be similar. We seem to have some color coding. Maybe Y, A, B, I have no idea what is this. Illegal opcodes. Why are there illegal opcodes? Hardware vector, NMI vector, not maskable reset vector, yes. ERQ vector, okay. So, how to do this? So we have, yes, I think I will just go with this text file, but I will download it instead. Where is the app? So let's download it in documents or in the emulator folder. I want to keep it and open, and we move it over here. The same location as before. So, just wanted to express my thanks for the help as always. Yeah, it is great to help. It makes me feel much better when I am helping. So that is why I prefer to do it. So okay, I can zoom in. That's nice. So, so my idea is I can go deleting the instructions that I have already implemented. This is why I downloaded the file instead of just using the online sources. I can still come back to the online sources if I need to reread one of the instructions, but this is how I want to move on. But burned by variable scope, being so long since I have had to deal with it. Well, that is strange because variable scope works the same on C# and in GdScript. You are inside an scope and you define a variable. That variable exists inside that scope, which is from this indent onwards until you remove an indent, that is, you lose one tab back. So it is the same. So on C#, you will use curly brackets to identify a scope, so where it starts and where it ends. But other than that, it is the same. We even use tabs to read them more easily. So it is more or less the same. I have seen. This is a little critic that I hope you take it nice, but I have seen that you try to do stuff without knowing if that stuff exists, just because it sounds logic to you. But the way I usually go is totally the inverse. If I need to use a function, I go and find what is the reference for that function, and I check what is the class of the variable that I am using, and go find the function and then see what are the class of the arguments that I need, and I see what is the class of the returned value of that class, and then I see if that callback will help me and what do I need to have that go working, instead of just trying stuff until it returns something that is not new. I am not afraid of searching examples, even if you are doing something that nobody else have done. In this case, making a Twich API with C# for Godot. There is that doesn't mean it doesn't exist. The same API for Unity 3D works just well because you are just using .NET classes to make an HTTP request, and it just works. So you can go and search and find examples and got them working. Even if not everything can be copy pasted, you can read them and see what they do different to what you are doing and see if it is better. So let's try to move on. So preferences, illegal opcode, version 2 from the same author. Illegal opcode, the 65XX CPU. So this is just bibliography. We kind of don't care of it. Changes since version 2.0. Version 2.0 was compiled with 2 Commodore 8-bit based lists found on the ether.net. Internet. There were some differences in the opcode names, so I included the other names too. Names between curly brackets are the names taken from the list compiled from Craig Taylor. Names between square brackets are the names taken from the list of Adam Bardi. So yes, what I care the most is the opcode, right? Using one name or the other, we don't change the disassembler. In worst case scenario, it is easy to use. In the end, we should use the name that matches the log file for whatever we are doing. So right now we need to what line did it fail? So we are on over here, self, and we should have a line counter or a history, or maybe here. Yeah, still the same. Okay, we are on line 5004, so we can find it. And in line 5004, here it is. It shows the first unofficial opcode. In this case, the no operation with opcode 04. And for some reason, it also shows some value memory. So it takes no operation and also another memory address as an argument, which is memory address, not a literal. So I wonder what is no operation. I wonder if it is something different than what I thought. So what would be the best way to go? We could go from this list from top to bottom, or we could go according to what is requested by the errors, and I think that is what I want to do. I want to go with the log file order until the entire test passes. So I will start with that. So the old list was also compared with other Atari 8 Git based lists. On the new things were found this list. The timing values, clock cycles, all from the opcodes were compared with the values on the list by Adam Barbie. There were no differences. The addressing modes for DOP, double no operation, and DOP instructions were copied from Christ Taylor list. The reason for this is that the different addressing modes explain differences in timing values. Opcode 8B was removed from the AAX table. The behavior of this opcode seems to be complex, as noted by several people. Maybe there will be more information in the next version of the document. For now, the opcode is called XAAA. The addressing mode of opcode A3, LAX, was passed on the previous list, changed to indirect X. The addressing modes of 13, blah blah blah. I don't care that much about the changelog. So okay, so this is from references for this table. OPC is the opcode in hex. This is mnemonic. Size in bytes and number of cycles. Okay, awesome. So that is all we need to know for now. Let's delete this and let's start with 04, which is no O. So I will search 04. It's probably $04 from what I am seeing here. And yes, so this is double no operation. So the way it's called in here is no operation. So argument has no significance status, so pretty common. So right before starting today, I added this task to do before starting doing this. I almost forgot. So I want to move the code. I want to rename the class that we have called NES CPU to CPU 6502, and then subclasses for the NES CPU. So I have a more order on what instructions are official and what are not. So I will rename this one class NES CPU, and we have how many usages? There is a couple that are not complete. So let's unmark them. This one I want. And these are just unit tests. Awesome. And this is another subclass. So let's rename this to CPU 6502. Replace all. Reload. And now we have all of this gone. And now we only have the room test that they should no longer be named NES CPU. This one is should be named. Yeah, all on the same file. So this one should have been named CPU 6502, and this one I will rename it to unit test 6502 CPU. Actually, this unit test is for the NES, so I should not rename it. I was making a mistake there. So yes, I want to subclass the NES CPU. Now this has changed the name. So let's see what do we need to rename. So in the file system, why is this showing like this? I don't like that. So we have NES CPU, NES memory, and NES ROM. This is more or less correct, but this is now coded CPU 6502. Let's put the underscore, and now we can subclass it in a new script. So we can inherit CPU 6502 in the new NES CPU script. So now we have a base class and a subclass, and eventually I want to move a lot of these functions about the common behavior to the base interface CPU, so it can be shared with other platforms like GdScript or something like that. Oh, Cricket. So you say it is funny because yes, I am using a library for Twitch chat, but it is just not handling the auth stuff. But yeah, it feels like with C# all I have been doing is referencing the .NET API and the doc from Microsoft. It is interesting to see the impression I give when I stream. Well, yes. So everyone has their way to do the stuff, and I don't. I am not trying to tell you to change that. I'm just telling you how it works best for me. I try to understand the types and the calls and the and the callback. So in my imagination, when I am coding, I kind of do parallel debugging while doing the code. So I am finding the errors while writing code just by knowing what is the type of the variables that I have, and what are the types of the variables that I need, and what are the type of the variables that I need to call the functions, and etc. So question, does it still run? Okay, now this has changed name, and that is because I did not give a class name to this. I am afraid I am going to need to suppress to remove the class names eventually, because it is a very bad idea to have a calculate memory if you want to distribute it in an asset lib. So I will have to remove all of them probably. Hmm. Or give a specific or give some prefix that is unlikely to be repeated. I don't know. So let's see. Oh. So now for my original 6502 view, I can copy the start of this, the init function, and paste it in here and change it. So first I will call super, and super will make sure that the previous init is called, and then I have to just register the new instructions in the same way I have done it in here. So I also need this for loop that will take care of registering. And now I can start adding the new opcodes to here. So let's just take one of them randomly and paste it here, and rename it to no op. And I want to also somehow identify that this is a new instruction, and one way is annotating it in the opcode class, but I don't want to pollute the opcode class with the stuff that is specific for the NES console. So instead of that, I will add a meta to the instruction. So I will say instruction set meta, and we'll give it a name like CPU name, and we'll set it to NES. So I can probably do the same in the 6502, or if I am doing that, I could put it on the opcode class. Probably, I don't know. Decisions. But for now, I will. Let's do this. Let's put is NES or is illegal, and put it to true. Because the only reason why I need this is to print this asterisk in this file. So let's continue moving on, and I think I have done unnecessary changes in here because the 6502 has a reset value that is setting. Okay, so I need to change this reset function for the NES CPU, and the reason is because I want to still call the same but set a different memory address for the starting the program. And that memory address should not read it from this. Instead, I want to specifically set the program counter to 8000. Which I believe it is what we did for the unit test. So let's see. Instruction trace ready, did a reset and set the program counter to this value. Okay, it was not 8000, it was 3000. And what else did we do in that class? See, so we did reset the CPU, and now that we have reset changed, we don't need this anymore. So what is throwing errors? Okay. I see something that is not helping. So let's reload the project. Yeah. So this one, convert to issue, and let's commit this change. Give me a second. Hit the status. What did change? A lot changed. Git add import. Oh, right. Because it basically is changing the content. We no longer need the unit test that I have been writing during hours, because now we have this cartridge unit test that tests all of the instructions at the same time, making all possible changes to the memory state. So if I would knew that this was going to happen, I would not have wasted so much time creating those unit tests in assembler machine code. Hold on. Just a couple more. And let's git add add-ons, retro console emulator, test, NES test. Okay, now I can add from here. So now it's choose the new GdScript file. Git commit and rename class NES CPU to CPU 6502 and make a new NES CPU subclass from it. Close this. Which one was it? 48. Git push origin main. Okay, now I am ready for getting started. Doing new code. Minimize this, and let's start with the double no operation. So we have zero page X and another zero page. So we seem to have more than one opcode for the same operation. It is kind of repeated, which is interesting. Anyway, so let's go like this. No, NES CPU, the new NES CPU. Why is this throwing up an error? Oh yes, this is not correct. Yes, let's amend it and push it. Do not do that in your project. So we have this, so let's create func double no op double no operation, and let's name this, let's just make fast. So the only difference is how many cycles it takes, but we don't write cycles right now. So it takes 2 bytes of size and 3 cycles. So this is a double no operation. It has no register. And 0 page. It's duplicated a couple of times. I forgot the parentheses in here. So damn, this one's supposed to be 2 and 5. So we have 4 and the other 0 page 44. We could, how do we mark it? We cannot give bold or italic or whatever here, so let's just mark it like this. 4, 44, and 64 are 0 page. Okay, correct. And all of them are 2 bytes, 3 cycles. And now we have 4 for 0 page X. 1, 2, 3, 4, 0 page X. And it is 14, 34, 54, and 74. So double no operation, memory address, they all take. Okay, so we have 2 with 2 bytes and 4 cycles, and the other 2 take 2 bytes and 3 cycles. Wait, no, I am mistaken. All of them are 4 cycles. I was misreading. Okay, awesome. So what I am doing wrong? Okay, I made lowercase x, it is meant to be uppercase x. Okay, so we need a couple more lines. Okay, and we have 1, 2, 3, 4, 5 immediate addressing mode. 1, 2, 3, 4, 5 immediate addressing mode, and they all start with an 8. Is that right? So let's see, it's 80, 82, 89, C2, and E2. Those are all the no operations for immediate addressing mode, and they are from this line. They all take 2 bytes and 2 cycles. So these ones takes 2 cycles for immediate. So all the immediate are done. And we have a couple more 0 page X that I did not read before. So let's move them up. And they are going to be D4 and F4. D4, F4. They have 2 bytes and 4 cycles. And they are 0 page X. Okay, we got all the non-op coded in here. So now, if I run this, I should have similar results, except I will have an error because of the missing star symbol. Okay, double no operation is not awaitable. Wait, invalid call function expected 0 arguments, but I am not passing any argument. What are you complaining about? I'm making a call without any argument. What are you complaining about? I see. It's because of how I programmed the addressing mode. So because I am passing an addressing mode, I need to ignore the addressing mode. What is it? Addressing mode. Spell it correctly? Apparently yes. So how about now? Okay. So now we are in a new opcode. So that's cool. And as I was saying, we got errors because we are missing this asterisk. And now we can fix that in our tracer. Looks like my music stopped. Let's search a different playlist for a change. How about this? Nah, it's too calm. I think this is the same one I was just playing. Okay, let's keep this one. So, let's fix this. So there is a point in our trace where we are printing the disassembled. Here it is. Okay, for some reason it stopped working, apparently. So let's just reset. Okay, what did happen here? Ooh. Something weird happened there. Okay, disassemble. So see, this one shows exactly what I wanted. It shows the mnemonic of the instruction, and I want to replace this character. So let's make it out plus equal, and put the mnemonic in here, and now I can start out with empty, or better yet, star if instruction has meta, and how did we call it? Is illegal. Else an empty space. And now if I hit run, no prints, meaning that it is working, because I only print when it fails. Cool. So I will push this first. So we added no operations and fixed the tracing. Implement iLiga start no op instruction and fix print of iLiga instructions. Let's name this trace print. Okay, cool. So now the instruction that is failing is opcode 12. Let's bring the calculator, and decimal 12 is OC hex. So in my file I already implemented the double no op, deleted, save, and let's find OC. And OC is the top no operation, triple no operation. What did happen? Okay, here it is. So it is the mnemonic is top and it is triple no operation. So let's just register it. Double, nope. And let's move down. And this one is triple no operation. And let's call it top double knob. This is OC. Call it top, and it is triple no operation. And now we can create this function. Pass it. Okay. And we can start fitting this to have the right size and number of cycles. So it is 3 bytes and 4 cycles for everything, except these ones could be +1 if it goes to the next page, if I remember correctly. Is that what the star means? Add 1 cycle when page boundary is crossed. Yes, as expected. So I am not yet concerned of cycles, so I don't care of that. So this one is absolute, and it should be O, and the next one is absolute X, and yeah, they are all exactly the same except of the opcode. So let's say I need 1, 2, 3, 4, 5 more. 1, 2, 3, 4, 5 more. And let's change the opcode. 1C, 3C, 5C, 7C, DC comic, and FC. Okay, awesome. And if I run it, should work. Famous last word. Okay, next opcode is 26. So let's commit this fast. git add git commit add iliga top triple no operation instruction. Oh, this is add. Awesome. So this one goes away. No need it. So next is 26. 26 decimal is 1A hex. Search 1A. And we have another no operation. Are you serious? There is a lot of no operations instructions in here. Okay, so it is also called no operation in the print. The top one. I wonder, all of them or only OC? I wonder, why should this be printed equals A9? I suppose I will ignore it. We can find out quite easily. Let's see if we have one C in the log file. Okay, here is the 1C on line 5045, and we are on line 5015, and it is no op. So we have all of them and they are all no op. So that settles it. They are all no op. And that also means we have to name it no op for this other. So nope, top simple, double, and triple no operation, like this, right? So we can just keep adding stuff. So this one takes no addressing mode, it's immediate. So I guess that also means we can just use no operation. Function call. And no operation does exactly the same, and get rid of double and triple no operation functions. That's more simple. So let's duplicate this line, change addressing mode to immediate, change the code to 1A, it's 1 byte and 2 cycles, and all of these are exactly the same. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. No operations. And it's 1, 3A, 5A, 7A, DA, and FA. And we are done with this no operation. Let's rerun. And we have a new opcode, but it's opcode 4. What did happen now? Did I break something? Ah, I see. This no operation. Okay, I will have to rename this function after all. Let's name it illegal no operation. And the reason is because this one takes the argument while the other one doesn't. Okay. So this is for some reason printing stuff that shouldn't, and it is immediate but doesn't have a byte. I see. So we have to avoid that. Let's say if instruction dot size bigger than 1, and only then we are going to do this part. Okay, and now we are to a new opcode 163, and it is A3. Search A3, and is a lax instruction. So it is load accumulator and X. So it's load A and load X with the same value. This is strange. So this affects 0 and negative only. And they are loading the same memory values, so it makes sense. Okay. Yes, do that. So let's find load. Actually, I want to see something in here. How those lags look like. Okay. I want to find load register 8. So this is going to be many registers, and it's going to be register an array of registers and the addressing mode. So let's go with LUX, which is instruction A7 for the first one, and do we care of this? I think not. Actually, yes, we care of register X, right? Probably. But how is this used? What was register used for in the trace? I am not liking what I ended up doing here. Okay, so there was a specific list that needed to dump the register. This is why I used that. But it is not the case, so it should not matter if I don't write it. So I think we are safe. Just put the string name. An addressing mode is 0 page for the first one. It's 2 bytes. 3 cycles. 1, 2, 3, 4, 5. So it's A7, B7, AF, BF, A3, and B3. Okay, looks correct. So it's 2 bytes, 2 bytes, 3 bytes, 3 bytes, 2 bytes, and 2 bytes. And this one is 3 cycles, 4 cycles, 4 cycles, 4 cycles, 6 cycles, and 5 cycles. This is 0 page Y, absolute Y, indirect X, and indirect Y. And now we have to use the load register function and implement it, which is very simple. For register in P register, let's just call the other functions. Load register 8, passing register, and P addressing mode. And this one will update the flags and everything. We'll read the memory and set the register, blah blah blah. What did we do wrong? Oh right, I never found the callback. Stupid. NES ROM. No, NES CPU. On this one I passed the string name, but I need to bin the array in here with register A and register X. So now what will happen? And it is trying to convert a callable into an array. I was afraid that could happen. Alright. I cannot put a breakpoint in there. Let's see what happens in this case. So this load registers already has a binding, and now it will bind an addressing mode on top of it. So when it tries to call, maybe because of the order of the bindings, this needs to be inverted. Okay, cannot convert argument 2 from null to array. That's strange. Hi, hello Savvy. How is it going? Your profile picture is so cute. Thanks. A friend from my local community drew it for a game jam where we was making a pixel art game. My voice is amazing. It's the first time that I hear something like that. Can you test my web app for a sub? I am not interested in subs, so just give me your web app and I will give it a try for free. So what is it about? Okay, algo, newbie, problems, and avatar. So let me see if I can read your messages. Thanks, I appreciate it. It's like a Let Code clone with pixel art. I don't remember something about Let Code. I like a lot the pixel art. I like how this shadow comes here, and I think it looks nice on widescreen, and I assume it looks also cool on mobile because of what I am seeing here. So let me try to remember, how did I set this? Okay, this is how it looks on mobile. Okay, this goes to a menu in here. This one could be more descriptive, like when you press it, it is appearing in this and it is not showing a container or something. I would prefer to have something floating on top on here, like if this is a menu, like pressing it, like this menu here, it pops another menu on top. I would prefer it like that, so no, we don't have this abrupt movement. That even in worst case scenario, I would prefer this to be aligned to the left, and if possible, have this container animating, so it is not so disruptive for the user. I like this pixel art. Did you draw it? I like it. So we have hammer, an axe, a skull, a knight. This is a slug. This seems to be some smelter or something. And I suppose this is a mold where there is someone is doing smiting on it. I will animate it. Yes! Fear array the terrible. So you have a link here on array, but doesn't seem to do anything. Is this supposed to be a link? If it is not, it is confusing because the rest of the links uses almost the same color. A master manipulator of arrays whose wickedness knows no bounds. Wickedness, sorry. He delights in inflicting torturous problems on his adversaries, leaving his foes tangled in a web of complexity. accompanying him in his trusty slog, Slimothy. Oh, that's an awesome name. So, a slug that makes smithing. That remembers me of this character from Daedalic. Call it Spot. No, not Spotify. I don't care. I don't like Spotify. Nope. The Whispered World. So this is a Spot from the Whispered World, and it could have different powers by eating different stuff in the game, and they could transform, and you used him to make puzzles and things like that. So he converted depending on what he ate. So in here he converts in paper. Over here it was fire. Over there it was small spots, which was balls, like this one. This one inflates and flies. So yeah, this is the Whispered World, but there is also the sequel called Silence, which was a nice evolution for Spot. So yeah, I think this is kind of a dev screen about how they changed it on during the development. So it ended up like this on Silence. He looks funny, yes. But this is how is it called? Caterpillar. Hey. Okay, Sappy Boy, thank you for the follow. It's great to have someone on board. So still you have the floating form. You have this. It is a caterpillar, and he eventually mutated into a butterfly or something like that. But that was just a dream, don't worry. So this is all 3D environment, quite novel for them, because they do mostly point and click games, and all of them was 2D until this point. Maybe Memoria had some 3D, I don't know. I don't remember right now. I have lost my Memoria. Anyway, you made me remember of Spot with that character. So we have problems. Add find index, type is a warm up, find index is a loop, get frequency, loop and store, find single, loop and store, choose zooms. Oh, it's a boss fight. Okay, it's interesting. Another thing that your app makes me remember is, I don't remember the name, but there was a game of deadlocks for threads. Maybe it was like this. Nope. Thread deadlocks. Yeah, this one maybe. No. Okay, yes, I think it is this one. So see, you have this code, and the music is a little high. I will release it in my headphone. Okay, now I can focus. See, so you have code in two parts of code are running on two different threads. So you have to step over, and eventually you can find a clash on the thread and make it lock. So yes, this is again, that helps you to identify under what circumstances threads can end up clashing and creating a critical error because they are reading or writing to the same memory address at the same time, or because one has to stop it waiting for a condition that will never happen. So that also should not happen. And your game made me remember this little game. Yep, so I will copy this and paste it for you. Okay, so let's try some of your problems in here. Let's make an add. Let's hide this for now. Does this go to your social network or something? Okay, it just goes to the same web page. Okay. Add warrant. Write a function that takes into integers and return the result. But this is already solved. Is there a reason why is it already solved? Caffeine, the magical elixirs. Okay, this doesn't read nice in mobile. See, so you have to make this pop-up to have a minimum size that for mobile versions. So you scroll in this, or you reduce the size of the label, or you allow it to be a little taller, but not much, because this is a pop-up and you want to maintain that, right? So add to your avatar coffee, tea, or bath. Next. Write a function that takes an array of integers and takes a target value. The array will always contain exactly one unique occurrence of target value. Your task is to print and return the index of the target value in the array. Okay. And this is JavaScript. Oh, okay, I can change it to Python or Swift, apparently. I don't like any of them. So let's say I equals 0. Oh, not even that. For each ball in array I don't remember JavaScript. If ball equals target return a plus plus. Let's submit it. Yes, I saw I can change the language, but I am not especially good on any of these. Let's do the same here. For what is it like? I can make I bar on. How do I make? Yeah, just I in range target. So len. Oh, that works. If array sub I equals target return y. Just for the sake of completeness, returns -1. What? Okay, codes are not very interesting. I don't even have a line 7, so I don't know what this error is about. So you may want to check that out. Mm, right, this is the length of array, not of target. Duh. Okay, now it passed. Yeah, let's have a coffee. Yeah, looks a lot like my avatar on Twitch and on everywhere else. Hmm. So write a function that oh okay, I have to go to the next one. Get frequency, loop and store. Write a function that takes in an array of integers and target value. Your task is to return a 2 and the number of occurrences of the target. Okay, so let's do count equals 0 for val in array if bar equals target count plus equal 1 return count submit pass it. Next one, loop and store. Write a function that takes in an array of integers where every element appears twice except one element that appears only once. The function should return the single unique element. I see. So let's say um, occurrences. I don't know how to spell occurrences. Let's call it found, lost and found equal an empty array for val int array if lost and found has val lost and found eras val else lost and found append val return lost and found 0 submit. Oh, I did something wrong. Um, maybe it's not eras, maybe it's remove or something different. I don't know the API of Python. I could use find instead, bigger or equal to 0. Mm, so let's try to find this. In the first one is giving 24274778. I am not sure of what I am doing wrong. Mm, I like that when you are on widescreen it shows on 2 columns. So I was looking at the phone version just to give him some insight on it. But this is also cool. So see, this pop-up looks more like what I would have expected for the more button in this. So this looks cool. So yeah, it's a little confusing that you use the same color for titles and for buttons, but it's quite cool, honestly. And the editor is quite advanced. I don't know if you have used some built-in editor or something. So what could be the meaning of this error? Do I have something in console? Maybe clear it and submit it. So test error, standard error. There is an error in code 9.9. It doesn't show anything meaningful. Hmm. It's failing your test case? Okay. Um, Maybe what it expects is... No. It did not like it. Is it the find method? It's find single. The loop and sort find single. So I will return to problems and go to the next one. Sum2. So write a function that takes in an array of integers and a target numbers. There are only 2 special numbers in the array that add up to the target number. Return the sum of the indices of the special numbers. Ooh! So you are going tricky here. Let's go for I in range. Let's make a size variable with the len range of size for j in range I size if array sub I plus array sub j equals target, return ij. Submit. Oops. Okay, this one failed. So 3 and 3 should have returned 7. So this is 0, 1, 2, 3, 4. Oh, the sum of the indexes. Okay. It's y a plus j, not the array. Okay, now these two passed, but this one didn't. So it is 0, 1, 2, 3 and 4. 3 and 4 are 7. So what did I do wrong here? Maybe this is size plus 1. Because I don't know if Python is inclusive or not. Okay, that it didn't like that. Oh, this one does not need to be plus 1. Okay, it still does not like it. So I don't know if range is inclusive or not on Python. Yes, you need to add the indexes together. Yes, I am doing that. Maybe I can print this. And if I submit it, what do I get? There is this 631. Now it has 5. Let's clear this and run it again. I think it did not print this because I don't see any printing here. Mhm. So we are reaching. No, we are not. First round, second round. Yes, I am not sending the same index twice because I am going first from I to size and then from oh, it's I plus 1. I see. And now it passes. Awesome. Okay. Very interesting problem. So this one, did you fix it or do I forget about it? Uh, so for I in, let's make face equal length of array. For Shay in range I plus 1 size if array I equals array Shay, then we are going to break it. Let's make a font equal false. Okay, it's uppercase false. Font equal true if not found, return I. Oh, the element, not the value of the array. Array sub I. The one that is not repeated. Okay, syntax error. Where did I fail? Size len array for I in range. Found equal false. I don't see an error. Maybe it does not like the break. No. Okay, we'll forget about it. Anyway, I had some fun here. It's a nice, it's a nice application, a nice game. I hope you continue with it and show me it later again. Thank you for trying. Thank you for showing. It was quite interesting. Let's find another music list about this one. It works. Okay. So in case you are not in sync with the stream, what I am making is an emulator of the NES console, which is the console that had the original Super Mario Brothers game, the original Dragon Quest, etc. etc. The Nintendo Entertainment System, and I am making it on GdScript, and the idea is to distribute it for free as an add-on in the asset clip, so anyone can download it and put an emulator in the games they make. So I don't know if you know of Godot or anything like that. This is the way it is. That's a great idea. Thanks. That's a wonderful idea. Okay. So I am getting this breakpoint. And yeah, I am still getting an error. Because it is calling bin twice, apparently. That is the only explanation I can think of. When I am calling call, it is setting the about this bar cb equals, let's just make if it makes a difference. Oh, it's not callback, it's callable. Duh. I need to remove this. Oh, you're okay. Go to school. I don't want to cause you problems. So it doesn't like this. Okay. Hmm. How to solve? How to solve? Instruction. Callback. Get bound arguments count equals 0. Only if it has 0 bound, it will add the rest. Let's do it like that. Okay, it's the same. Why is that? Why it thinks that the argument is a callable? What is callback? Instruction. Callback is a callable but doesn't give me any other information. It is lags a size of 2, 6 cycles. Am I doing something wrong? So if let's say, I duplicate this line and comment this to keep it, and then remove the argument type. Then try to run it. What do I have here? Register is an array. Are you joking? This is an array of registers. Why did it fail before? If I uncomment this and comment this one, cannot convert argument 1 from callable to array. Why does it think the argument 1 is a callable? It's not a callable. But if I do not type it, okay, now it doesn't, if I don't type it, it doesn't get an error. Did I mistake with the type? Register 8-bit. What is this? Register 8-bit. Maybe if I do this, it does not complain. Doesn't make sense to me, but I want to understand what is the issue. It still complains. It's very strange. Okay, I give up. No type. Actually, let's remove it first. And now let's remove the type. And erase this line. And now it continues. So let's see, what are we failing on? So this no operation failing to put a value in here. So I don't know why should it have a value. So this one, AF, thinks it is index Y, but the print does not match. So it's AF, sorry, it's absolute Y, not index Y, absolute Y. And if I look at my top, okay, indeed it is not correct. So let's review this. Let's hide this for a moment. And we have 0 page, 0. Wait, this is not black. Where is black? Search 3, okay. Okay, I think I am changing code editor. Okay. To something else, because I am having a bad time using Notepad. Let's move this to the corner as before. Okay. So now let's find flat, and we have A7, B7, AF. Oh, we have AF twice. That explains the issue. BF, A3 and B3. So now let's rerun, and we got to a new instruction that is unimplemented. So for some reason, absolute is expecting to show memory value, but it is not doing so. So let's see our trace. Trace, absolute. Okay. So there are some particular instructions that takes this condition, so make another OR instruction dot has meta is illegal. So any illegal should also have that equal condition. Okay, and now we are out of error. No more errors. So let's commit these changes. Yes. Yes. What? Oh, it's a big change because I changed the indentation. Okay. Git commit and add illegal flag instruction. And let's say code A and A. Okay, custom. So now we have we are done with flag. This is much easier now that we have the unit test already implemented and we don't have to implement our own. So the next instruction is 131. So 131 is 83 in hex. So let's find $83 and it is AAX. So it's an AND X with accumulator and store the result in memory. So it's a very specific instruction and I kind of see why they added it, because it was a lot of instructions to do it manually with assembler. So I don't think I have anything similar that exists. So it's let's duplicate one of these and let's start changing it. AAX. And register so let's do register A, register X, and addressing. And now we have to create a function. Register 1. Is this correct? The name of the class? Yes, it is. Register 1, register 2, yeah, addressing mode. I think I can make it shorter version. So now I can search for the previous AND operation. Oh, this is base CPU. So I want the NES, no, the 6502 CPU. One. And I want to search AND in here. Okay, let's put this. Let's rename this. Bitwise AND 2 registers. And let's rename all of these. Okay, only one. Okay, and addressing mode, and let's see what was this. Oh, let's comment this and let's say var result is of type integer equals reg1 and reg2, and I should not forget to say value. And this goes result, and I need to store the result into the memory address. Memory write address, which is this one. We did not need to read it. This is this hand is done. This is address and result, and this should work. Famous password. So now we need to fill the page. So it's 1, 2, 3, 4, and the opcodes are 87, 97, 83, 80F. All takes 2 bytes. This one are 3 cycles, 4 cycles, 6 cycles, 4 cycles. This 0 page, 0Y, indirect X, and absolute. Save it and let's give it a shot. And we got to the breakpoint statement. So apparently it was named stacks instead of act, and we are carrying an error. In the program counter. So let's rename this to stack instead. Wait a second. Is it really the same? 83. Yes, it's 83. I don't see why call it stacks, but okay. Because S is for store. doesn't make much sense to me. But I am not an expert. So now, what is going on? Is there any other 83? No, it's the only one. So it cannot be oh, this one has tags in parentheses. So I suppose that is what is used. And anyway, so what did fail for us? We expected an E6 flag, but instead got a 64 flag. So the one that is not matching is the 0 flag, apparently. We should have a 0 value, but it is not a 0 in this. So A is E3. Sorry. C, A is 3E, and X is 17. So there was some matching, so it should indeed not be a 0. So let's try to make a breakpoint and see what is going on when this is being called. So we are getting the address. Address is 68. Register 1 value. And let's see. Register 1 value is 62. And X is 23. Let's see that. And 62 3E indeed, as we was seeing. And the other one is 23, which is a 70. 70, and the result is 22, which is indeed kind of what we was looking earlier. So it is indeed non-zero. So when it updates, both should be false. So what did fail in here? Maybe the flags are not computed according to the result. Zero negative. I will go to the sources of the example and see if they take the zero negative flag from a different source. This is the last resource, so back. So it takes data is oh, interesting. It is not changing any flag for the sack. So that would imply that this documentation is wrong, because indeed it is not changing anything at all. So that is interesting. That means this is not necessary at all. So now we got an LDA that failed. And because of that, it is being carried. So it should be loading the value from this memory address, and it was meant to be 16, but it is not. And we need to find out why is that the case. So some previous operation was meant to write this 16 value to this memory address, but it failed. And there are a lot of branching going around right before this. So what we can do, so for h in range minus 10, let's say. 0 range was inclusive or exclusive? I think it's okay. It's exclusive. Okay, B and N are inclusive and exclusive. Okay, so 0 is fine, and I can change this for a single print using A. Now I should have more lines before that, and we could try to find when did this memory address get changed. 0489 branching. I don't know when this happened. I have no memory of this place, so maybe let's add a logger to this line. So this is the CPU bar observe. It is a memory observer equal CPU dot memory dot create memory observer, and let's just use the exact value for now. Flags, do we keep the defaults? What are the defaults? Both are read and write 8-bit. Can I see that? Yes, it's read and write 8 bits. So yes. And now that I have the observer, I can connect it. Function. Print. Memory. OX and this. No. 0489 was what? So memory read. Let's see. Read. Oh, sorry, the variable has address and value. The address old and new value. Address value. So this one is read mem. So we can make this. I think it is percent 04x, I think. And percent 02x. So the arguments are first the address and the value, and no longer need argument. Okay, this is missing a operator. Value not val. And this is old value, new value, and this is write mem. And we could inline, put this and print line here. Memory, change it from to %02x, inline C. So we have address, old value, new value, and line. Okay. Let's see how this goes. So what did we get? So in this instruction, it captured the change. It says it was read. Yes, makes sense. So we only have read of that memory address and never write. That is a problem. But we have the lines where that happens. So we can try to it is 5. So this is all happening in 5540, and this is happening on like 5020 onwards. So 505,019. This is the first time it is loading. It doesn't make sense. It is not reading the memory on this line. It is reading it on the next line. Okay, so it is line +1. Okay, so let's fix that. Okay. So let's find usages of this memory. And we have 3 references, sadly. Okay, more if we remove this. So I think this tag is meant to be storing the value on this memory, but it is not. P and 30. For 489, it was 0 before the stack. I should have been 16 after, because 16 was the result of this operation. Okay, 16. So whatever happened, it did not write in the right memory location in our NES CPU. So let's take a look at that. So we have a result. Result is 22, which is 16 in hex, and it should be writing it to the right address. Addressing mode is line address 68. Why is address 68? Oh, I see. So I changed these ones, but I never changed these ones. This is why it is doing the wrong thing. Ooh, that was savage. Need to pay attention to that. So now address is indeed 1161. And now, okay, it did not say it has row, but maybe it's just because it will happen in the next one. So what about 9? So I never connected the right signal to the right print. That is why. The third memory write to right man. That explains it. So now I can pick reading and writing the value of a specific memory. Okay. So this seems to be working, except this one. Okay, absolute takes 3 bytes. Instead of 2. Makes sense. So 3464, the rest is correct. Okay, now everything passes until the next failing instruction, so we are ready to commit this change. Git status is add. So we have the new instruction, the new function. I don't want to add the observation. I do want to add this change to the print. Git commit. Implement illegal sucks bitwise and to register. Instruction. Okay, awesome. Pushing. So how are we going? We are online. Where are you? The line. Is it on self? Counter, register, flag. Right over here. So what is the line variable? Should be here. Can I hover it? Alright, we are inside the class. So about to execute, still on the class. This one. And here we should have the line. No? It's still inside the class. This one. Okay. 5,700. 5,728. RTS. No, SBC. This is the one that is failing. So opcode is 235. EB as expected. So stacks goes away, saving, and now we have to find EB. This is going to be the last today. It's immediate, and it's only one, the same as the legal opcode, so it is literally the same SBC. So should be very straightforward. Maybe let's make another one after this. NES CPU, duplicate. This is the opcode CD. It's named SBC. As the previous one, it takes 2 bytes and 2 cycles, and it's immediate. And let's see if we can use subtract. Let's see if I can find it. Subtract with carry to register. Okay, we have to pass the register. I suppose it's register A. So no bin. Register a.name and immediate. So does it pass now? Looks like. So now we are online. Where is my line? Okay, here. And 5,800. Okay, awesome. So this was, it's done with the SBC. Saving. So what is next? So it's 195. 195 and it's C3. Let's find $C3 is DCP or DCN. Subtract 1 from memory without borrow. Let's see in here. What versions do we have? Decreased. Okay, it does increase memory. And increment memory. Makes borrow. Zero and negative. This one doesn't. It only sets the flag. So can I choose or increment memory with addressing mode? This is called DCP. So how was it used? Int -1. Let's try to use it as keys. String name. And let's copy the rest. So it's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. C7, C7, CF, DF, DB, hello, Elfman. Each game has its own thinking. Well, that is the thing. We are not making a game. We are making an emulator. So the idea is we can play any game with it. So this is D3. This one is D3. So I don't know if we will be able to play every single game, but we will try. We will see what can we play once we finish. So this one is 0 page, 0x, so absolute x, absolute y, immediate x, sorry, indirect x, and indirect y. And now the bytes are 2, 2, 3, 3. I'm reading from here. 3, 2, 2. And the cycles are 5, 6, 6, 7, 7, 8, 8. Yeah, like some games use custom opcode. So this is the thing. The base CPU for the NES is the 6502, which is a very common chip. This is the 6502. It's like something like this. 6502 AD, and the NES uses a superset of it. So we already have 6502 running in our emulator, and right now I am using the opcodes that are specific to the NES, which are this list of here. And what I am using is running an community created test ROM. So I am loading a ROM file, an NES file, and the way that it works is I am making prints of the state of the CPU before and after each instruction, and I am comparing that result to a log file that is provided by the same people that provides the ROM file. So whatever I make, I should have, if my printing matches with this printing, that means that our emulator is doing the right thing. In that way, I found an example that one instruction that in here said it was updating zero and negative flag, it should actually not update them at all. So yep, that is how things are right now. So we are about up to this line without getting errors. All of this does not produce any error until this line, as I was saying over here. This line, more or less. We are adding one new operation at a time, one new opcode at a time. And see if they all work as expected. So this one, pilot expected 2 arguments. Why is that? Increment memory. I found an increment memory takes 2. What is failing? Instruction is DCP, yes, size 2. I see. I see why this is failing. It is because of how I changed the code earlier. So let's go full screen again. And what we have to do is also binding what? Okay. Also binding these values, comma, and add the addressing mode. Save. Okay, sorry about that. It should be before the -1. We are more or less fine, except our no operation. No, sorry, it was not the no operation. The DCP has changed some flags, and it should have not changed them. So what did change? So before it was 64, and after the change it was E4. So what did change? It changed this flag and only this flag, and I think this is the negative flag. Is it? Let me confirm. Yes, it's the negative flag. Oh, that could be because this one says it only changes the carry flag. That could be the reason why. So let's make another function. Increment memory, no borrow. Let's copy it on this one. Let's copy it as is without asking for now. Let's copy the arguments as well. Okay. So we are getting the memory, reading the value, adding or subtracting, making the change, and in this case I think I want to set the flag. So flag C set for its value equal true, and do the same in this case, and don't update 0 and negative. I think this is what we want. So let's run it and see how it goes. Okay, it is still changed the flag, and that should be because I never changed the function that is going to be called and running the instruction. Let's go ahead again. So now it still changed it, but with a different result. It expected to keep a 5 but changed it to 27. And why is that? No, it expected 27 to change it to a 5. Kept a 5. Expected 27. Get the A5. So what did change and should not have changed it? It changed 0 and it changed it. Okay, this is right. This is wrong. It's a very different value. Maybe should have indeed called it update 0 negative. What happens now? So strange. Let's comment this. Run again. Is it the same line? 20, 58, 28. This one is now 58, 51. So it was happy before, but now it didn't like to not update it. So what is going on? DCP is what we are making. Let's remove these Printing. Deleted. Yes, comment this, comment this. So this one expected to change A5 to 27. So A5 was expected to change to 27. So it expected to change negative and expected to change 0 flag. And the result is actually 0 from what I see here. Because 27 is the expected result. So apparently the problem is not TCP, the problem is that this memory was expected to be a 1. So after the decrease, it would be a 0. So why this memory is not setting properly? See? What is happening with this memory? Okay, it was set from 0 to FF. At this point. $45 plus X, 47. So 647, 0. Okay, it is not doing the subtract, what I am thinking. TCP, wait, TCP, yes, it is subtract. And this is C3. C3 is indirect X. It was meant to be a 1, but it's not a 1. In any case, this makes obvious that it should be updating 0 and negative, but that is contradictory to the other line. It was 64 and changed it to E4 and changed it to the negative flag and nothing else. It did set the negative flag because the value is EB. EB is indeed a negative value. So now I am confused. Does it behave differently from one to the other? Jeez. Maybe should update the 0 flags. What happens if I do this? It's still failing in the other DCP. And it's also... No, this is indirect X as well. Oh jeez. So let's see what is doing, right? So this is the first time we're on line 828. The amount is -1. The result is 234. EA. And if I remove this, okay, and it did much, but now this result is 255, but it was expected to be 0. Let's see this again once more. So the value was 0 before. Service mode 8. So before I get crazy, let's recheck this. 0 page, 0x, absolute, absolute x, absolute y, indirect x, indirect y. Okay, they are matches. D7, D7, DF, DF, DB, D3, DC. Okay. So maybe no borrow means no, it doesn't overflow. Result equals 0 and sets the carry flag and updates this. Maybe that is what no borrow means. No, it is still fails because it's setting the negative flag. So this one doesn't want a negative flag. If I comment it, this one 27 does not have a negative flag, but does have a 0 flag. Am I crazy? Yes, I am very crazy. So it expected a 27, but got an A7. So what bit changed? These three are equal. I got a negative value. But this one is not negative. 0 is not negative. So it expected to take the negative value. So this is annoying. Let's see how it's done in the example, because I am going to become crazy otherwise. So DCP. So address reads the memory, subtracts 1 and writes the memory. Oh, if data is less and equal than register A, that's the carry. Okay, and it does the wrapping. Let's redo that to have the wrapping again. And according to this, C equals result less or equal than register A dot value. That is totally not expected. And then 0 and negative is the result of register A subtracting data. What the hell? Maybe the description is wrong. So let's see what says on the other documentation. We have DCP here. Equivalent to decrease value when then compare value, except supporting more addressing mode. So it's decrease and then compare. So that was DCP. So let's rename this. Decrease, then compare register. So now we have let's instead call it increase instead of decrease, because we already named it increase before. Let's call it zoom or add. Anyway, I feel like the register should be here. Okay, so I can now go. Why decrease? Let it increase. Okay. Is it increased memory? So what's it called? Increment. Increment, and we pass the string value. And then compare register, and we pass the register and the addressing mode. And if this goes fine, what did go wrong here? Yes, we don't want putting types. Okay, it passed. Now we are getting another unknown instruction. So we can stop tracking this memory. In the unit test, let's stop tracking this memory. Awesome. And let's commit this. And I don't want this. So is implement illegal TCP decrease and compare. Git push origin main. So we have been online for about 3 hours and 15 minutes. So before I forget, let's remove this from my list of things to implement. And we are missing a lot yet, actually. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 instructions with different addressing modes. So I think let's continue on the next stream. So, thank you very much for watching, and see you next time. We're getting just a little closer to the goal of having the NES ROM fully supported. Bye.